Now, to start with, I would like you guys to have a revision of what we have gone through in the past 2 weeks in terms of thinking of typical reactions in organic chemistry. First of all, as well as some concepts about organic synthesis. Now, so I just see 2 latecomers. You just disturb me. Hey, Choi Jun-ming, late. Where are you? You're just late. And what you're going to do today is to take a look on this one again, okay? So I do think we start from this chapter. This will be better. So I need to change, I need to cross them out. Thank you. Thank you for reminding them. Now, shall we take a look on this one, the previous chapter, chapter 32. Now, before we continue on organic synthesis, any questions, anything that you have doubts, please let me know now on those 2 chapters. What are they? We just cover those important organic synthesis in terms of a map. That is the first thing that you have to memorize. You have to memorize all those details. It's not only about the reagents, the conditions for those conversion, but also the transformation from one functional group to the other. Okay, so I would think that most of you may have some confusion about the hydrolysis of ester and amide, the product, right? Because in the past 2 weeks I have listened to so many doubts on these 2, right? So I would like to clarify for you on that before we continue. This is ester. So we have got ester R, CO double bond, and then O, and then with R dash. So that's 2. Oh, I know the handsome guy is Cyrus. Don't tell me handsome guy is Cyrus. Cyrus, morning. You're late. Just say something. Cyrus. Morning.
嚇 late 嘅，
黎允正 I just started the lesson. So I would like to go through this part again. So ester, the hydrolysis of ester, we have got this. Can you please try to, if the case will be this, okay? Anyone, I try to put it as a real chemical name such that all of them can be treated as a practice. So I would like to mark it down as here, and I would mark it as CH3 here, and then CH3. Can you write down the exit hydrolysis product and alkaline hydrolysis product respectively? Anyone who can tell with that too? Cyrus, the one who can. I will not count you as late if you can answer. What? Pardon. Anyone who can help him? Do you know where we are now? Where we are? First of all, we are having chemistry lesson. Now you have to take the textbook 3B, turn to chapter 32. How about the others? Anyone who can help? Lei Tong, you should know that you'll be the second one to help answer the questions. Lei Tong. Hi, Samson. How about you, Cyrus? Tell me.
we don't know 發生咩事喎。
Thing seen, though. How about the others who can tell the product of this? Yes, this one, we call that methyl ethanoate, the ester of this. What will happen for those exit hydrolysis? What are the products of the 2? Just tell me the products of the 2. Okay, yeah. So 1, 2 has got the correct answer. This is you are going to split. How will you know? How you are going to split that apart and try to find which part is quite similar to which homologous series. So we have got carboxylic acid. This one is very similar to carboxylic acid. So what you're going to do for hydrolysis is to add H2O, right? But of course, H2O you can separate into two parts. One is OH, one is H. So having merging with OH on that will make it as carboxylic acid. While for the H here, I will make it as alcohol. Okay, can you get my point? So simply speaking, what is that? You are going to cross them out here like this, and then add an OH here. So we get ethane exit. Ethane exit CH3COH. Can you get my point? So this one O, I meant an H here. So you may get methanol. Can you get the point? Do you know what I'm going to do? So your turn, Cyrus again. Tell me what happened for the alkaline hydrolysis. Oh, vanish, disappear, or you just have the attendance taken and you just go back to the bed and sleep. Cyrus 係出現。Hello. How about another Cyrus? Yeah. How about this? Alkaline hydrolysis. What will happen to the product? We've got a salt of carboxylic acid and alcohol. So I can give you some hints. You may refer to that two product and try to tell me what will happen if I put this into alkaline medium. What will happen? This one, no change, right? So you may mark it as methanol. Yeah, Lazua has got the answers, right? So the source of carboxylic acid, which means this one react with alkaline. So what are the common particle found in alkaline medium? It is hydroxide, right? Hydroxide. So the F ethanoic acid, being an acid, will react with hydroxide ion to have a neutralization. So the product will be CH3COO minus. Okay. Why didn't I show you Na plus? Do you know? Because I did not tell you what alkaline has been added. So if I specify it as NaOH, okay, so the answer should be together with the cation, this is sodium ion. If I write it down as KOH, so the cation will be changed to potassium ion. So all of you can get what I mean. If anyone who doesn't know what is that about, could you please put up a hand? If you don't know, if you don't understand what I'm just saying. Oh, it seems no. So Cyrus, you just understood. You have to tell me what happened for the amide, hydrolysis of amide. We have got acid hydrolysis and alkaline hydrolysis respectively. What will be the product? So amide, I would write it down as CH3, then CH, CO double bond, and then NH2. I give you this one as example. It is a type of it's not N substitute. It's unsubstituted amine. Amide. So you are going to hydrolyze this one. What does mean by unsubstituted? The N here would not attach to any alkyl group. Anyone can tell? Hi, Cyrus again. No. Samson will finally realize what is happening, right? So carboxylic acid, yes, this one we call it CH3COOH. How about ammonium ion? Ammonium ion, it comes from here. So how would you know this is ammonium ion? Somebody will have for this part, I would like to show you how we deal with this. So first of all, you just split it again. That's very similar to the arrangement of ester. We are going to split it apart. Indeed, it is the point where the bond will be broken. Okay, and then you are going to think of hydrolysis. So hydrolysis, I need what? I need water, right? H2O. So how will you get that H2O? I will not stick that the whole H2O to either molecule. Instead, I would like to share this. Okay, so how would you like to share this? So first of all, each of one will get H, right? But the O cannot be further split into half O, right? So one of them will get an O. Can you get my point? So you are going to merge that two. So that's why the OH here, right, will be merged with here for OH. Can you get my point? So and this part, I put an H here. So what will happen to this? This one, the first one on the left-hand side will turn to carboxylic acid, while the second one, we've got NH3. How come it is NH4 plus? Samson, can you tell why? How come it is NH4 plus but not ammonia? Dissolve in water. No matter we talk about ammonium ion and ammonia, also or both are both dissolve in water. Could you please refer to the medium of hydrolysis? What situation do we have while you are having the hydrolysis? You will see one word before hydrolysis, right? Acid. What are the common ions found inside acid, which can make ammonia to ammonium ion? Yeah, that's right. So this is the reason, okay? So that's why for the product, we will get acid and ammonium ion. So you are going to think of the another way around, right? So of course, the major substance that you may find for neutral hydrolysis of amide will be carboxylic acid and ammonia. But in alkaline medium, ammonia will not further react. So I will write it down as ammonia. But for carboxylic acid, just like this one, it will react with alkaline. So what will we form? We call that a carboxylic salt. So the answer should be COH3 COO minus. So what is that cation? It depends on what? It depends on what? Yeah, it depends on what alkaline to be used. So if it is potassium hydroxide, I will mark potassium ion. If the hydroxide is with sodium ion, so this one is sodium. Okay, can you get my point? For those who really understand what I've just said, please let me know now. Put up your hand. You don't understand? Oh, no response. Just one. Just one I understand. How about the others? No? Oh, they didn't get understand. Okay. Right, you have understand. Okay, good. So you just stop it here. How about the other functional group? Do you find it difficult? Any questions? Any doubts? Now, if not, shall we go over? Yep, thank you. Thank you. So shall we go over to the multiple choice questions? Now, it's from question 2 to questions 12. Altogether, we have got about 11 questions. Okay, now shall we take a look on that together? Now we have got 16% here, right? 12 questions. I will select those students who still have an answer to try out those questions. Chen Zhenhei, question 2. Consider the following conversion. We've got this. And which of following combinations can achieve the above conversion? So we have got 2 steps. First of all, I will give you some hints. That is you have to find out change in the functional group, right, of those two cases. Now, we have got that two group, very, very strange, right? D. Agree? Yes, that's right, it's D. How will you know? So first of all, what is the type of reaction? What is the type of reaction for the first one? This is a type of hydrolysis, right? Hydrolysis. So by doing so, the intermediate, what is the intermediate? We've got a pentagon-like structure. We've got that two-ring structure, pointing out, pointing in, and this one you change it to OH, and this one you change it to OH. Okay, and what's next is to have a neighboring, okay, neighboring hydrogen atom, right, to get involved in the second step. We call that dehydration. Okay, can you get my point? So you need to be aware of the conditions. Something is missing here. We've got that too. What are missing? This part on the left-hand side, heating under reflux. Well, the second part, something is missing. What is that? You need to apply heat, right? Okay. Do you understand? So how about question 2? How about question 3? 李振傑 Can you please?
A.
A?
Yes.
Yeah, take a look on this one, the first one. First one, it is, what is the type of reaction? I use lithium hydride. Yeah. Reduction. Yes, that's right, reduction. So the intermediate to be formed is CH3, CH2, and CH2OH. How will you know that that one is carboxylic acid, three carbon to form 3 carbon primary alcohol. Okay, so that's what that the second one is called it what? Listen again.
Dehydration.
Yes, dehydration. Dehydration, which pull away the two water, one OH and one H to form one water to got propene. So, listen, you have to keep the mic on to tell me what is the third one type of reaction. What is that? Merging of the two molecules, right? To form one. Yes, very good. Addition without any elimination of substances. So we have got CH3, CHBr, and then CH3. Okay, so how come that the bromine is added to the second carbon but not the first carbon? Now we have got equal charge, is it? Hydrogen and then Br, you can put either hydrogen on the second carbon or the third carbon. Okay, why? What is the difference between these and this? What is the difference between these two? Cyrus, you? I accept. How about Cyrus and I check in? Cyrus, you, first of all, this one. Oh. How about the others? Like, what rule?
Markov's.
Oh, Markov's. Yes, that's right, Markov's rule. Markov's. So Markov's rule, what rule? Yes, major minor product, that's right. Which one is the major product? Which one is minor product? Now, first of all, the addition of the hydrogen halide to the asymmetric alkene. This one is example of asymmetric alkene, is to add the hydrogen atom already to the carbon atom of carbon-carbon bond already having more hydrogen. Okay, the answer is major product. Yes, that's right. This one is major. Now finally, oh, you have waken up, Cyrus. Congratulations. Yes, the bottom is minor. That's right. How about D? How about number 4? How about number 4? Luan Xiaowai, have you tried? Number 4. Take a look. Consider the following conversion. Now, first of all, you are going to take a look on the functional group. Functional group. We've got these. Oh, first change, right? It's not. Yeah. So what is that? It is amide. The same, right? But this part is now changed to ester. Can you have a try on that? Who is the next one? Luan Xiaowai, is it? Luan Xiaowai, hello. Luan Xiaowai. Hi. Slept again. 你見我 I don't know. 你見我 How about 唔問起？你見我 slept again? Hi. Response please. 你見我 Next guy 唔問起。Get prepared, Samson. You will be the next one. Exit hydrolysis. Exit hydrolysis, which is the first step of this is the first step of exit hydrolysis. Yes, but it is not only one step. Okay, so do you know why? Because you are going to have to think of 2 steps. From the question, from the answers, you may find that each of them do tell you different steps. Okay, so hydrolysis is 1 step to form what? To form this one. Can you get my point? So this is the second step. So the first step, I need acid. Yes, that's right. Okay, you can. How about the second step? How about second step? Samson. Hello, 李彤. Plus alcohol. What type of alcohol? What is the alcohol? Could you please make it more specific? What alcohol? Yes, methanol. Now, indeed, don't get too worried about these substances because it seems like a mirror image, okay? So what you need to do is to consider only this part, okay? Just treat this part as alkyl group and you just focus on this, okay? You just focus on this. You may find it's simply a conversion from carboxylic acid to ester. So you are going to add CH3OH. Because I tell you it's a mirror image, right? So you do the same. But this time the writing of this one is in reverse order. But the product is the same. It's the same because the alcohol is shown it as a methanol. Okay, can you get my point? So you refer to the answer. Which one will give you this one? Yes, this one, but not these 2. Okay. So which one is correct? A or C? A or C? Yeah, C is correct because C, which means what? A type of alkaline hydrolysis together with the acid, right? So you may find this one is C, acidification. Okay, so here comes question 5. Your turn. Question 5.陳偉豪. I will show the list of the people to answer the questions. I want to speed it up.陳偉豪, where are you?
Okay. Let me think先. C.
C? Yeah. C, correct. Is it correct? C. Now, how will you know this is the one? So you are going to have a hydrogenation. So this part aldehyde will be reduced to alcohol, but also because I add hydrogen, right? So they will also react with carbon-carbon double bond to form CC single bond. Okay, so this is the intermediate for P, and then for Q, what is that? We have got this one. This is oxidation. Okay, oxidation. So you may change the primary alcohol to carboxylic acid. Okay, can you get a point? How about question 6? Next guy, 劉文正. A little bit more complicated now. C5H10O. You did not know anything about the structure, right? You have to think about yourself to make up the structure. But one thing I would like to tell you is we've got that 1O only, right? 1O. So what is that? Compound Z is synthesized from the compound X as below. Now, from the type of a reaction, now from the reagents, can you think of the type of reaction actually? This one, the first one. Can you think it, right? I add this one, a very authentic example. It is a type of wow, Ricky Low. Just observe the time. 9:07. 盧少華, good morning. Hi.
早晨。
Okay. Don't tell me that you have got a traffic jam.
有 delay.
Oh, time lag? Or your Bangkok time?盧少華, you are going to get prepared for answering question 7. We are having question 6. This one is oxidation. Yes, this is oxidation. And then we have got ethanol, but consol, heating under reflux. What is the type of reaction? You may imagine it as a type of what? Only that pathway, right, in the whole map. Yes, you call that a condensation reaction. So in terms of this, it is a type of what? Ester. You may think it of an ester. Okay? Can you get the whole thing? So you may think it backward. This one, why will we what? A type of carboxylic acid, right? To have a carboxylic acid. So you may go back. So this one, ethanol, is an ester. So which part of that will be the ester? Ethanol. I put it here on the left-hand side, or I put it on the right-hand side. Ethanol, that's 2 carbon. Now, 温志偉, do you know?
我 have 啊。
Ethanol, here, you may think it backward, yeah. Right? Ethanol. So you may know that it's ester. What makes that ester, ethanol? Is it on this part A or this part B? You get that?
B is acid and A is
alcohol.
Yes, that's right. So this is the one. You have got the ethanol here, right? So you may check the answer COOCH2CH3 first. Can you get the answers? Which one? Okay, this is the one. Any other combination? Now this one is not. This one is ketone. This one is ester. This one is ester. But you may find the alcohol part. It is not ethanol. Can you get the point? So what will be the answer finally? This is D. Okay, you got it? All of you got it? So no need to take too much about. Maybe you can check the number of carbon here, right? So you may find that 1, 2, 3, 4, 5, right? 5 carbon, and that's it. So what is X actually? We have got this part and X, then it is the type of alcohol with this structure, CH2OH. Okay, can you get the point? It is pentane 1O. Questions? You find it tricky, right? So how about the other? You have a 1, 2, 3, 4, 5, 6. 6 more to go. I don't want to open the classroom again and again. We have got 3 minutes and a half only. Anyone who can tell the remaining answers? Question 7. Aspirin can be produced from salicylic acid according to the following equations. This part. What mass of salicylic acid is needed to produce this one as aspirin, assuming 40% yield? Yeah, you have to go back to something about calculations, right? C. How will you get this? How will you get this? The answer is C. Samson, how will you get this? Yep, that's the first part. Yes, very, very important step. 10.8 gram or divided by 40%. By doing so, you may have get the theoretical yield. Okay, theoretical yield. The theoretical yield it is 27.0 gram. Okay, theoretical yield. So what's next? Now we have got 10.8 gram divided by 40. We need to have got it as theoretical yield. This one it is actual yield. Okay, so we may get it as 27.0 gram. So this is the theory, the theoretical yield that you may find, and then you are going to go back to this salicylic acid and aspirin. They react. They would be formed in 1:1 mole ratio. Yes, that's right. You are going to divide it by the molar mass of aspirin. So we have got this one divided by 27.0 gram over 180.0 gram per mole. What will we get? It is a theoretical number of moles of the substance to be formed. Okay, so what is that? So you have got the mole, number of moles, right? Well, this mole, it is the same as this. Remember the times. Salicylic acid 138.0 gram per mole. So you may get the answers. Okay. So 7 is C. So I would like to end. I would like to have another chat room now. So I stop at question C first, but you need to finish the remaining. You are going to enter this class again.